Hey,
Hey, good to see you.
good to see you too. How's it going?
Pretty good.
Oh, nice.
Were you at Summit last week?
Yeah.
Yes,
Oh,
you
both
took
of you.
both. But yeah, I didn't see you. I met Ducky, but I didn't see
Yeah,
you.
I think I saw you, but I think I was far away, so I didn't go for the meet like that. But but no, yeah, it was fun. It's lots of stuff though. Did lots of talks to attend. So yeah,
Check. There should be a comment that he's coming.
Yeah, I think he's joining.
yeah. Could be.
There she is. He. Hello.
Hello.
Excuse me?
Pascal's also there. Okay. Always last minute. Yeah, but it was fun. The hotel was good where they did it. Like the location was really great. I have
Oh
to say.
yeah, no, we had a summit there in I think 2019. So I
Yeah.
do remember. It was yeah, I really liked the what they call the atrium.
Yeah.
Um,
All
It's
the
very
water features.
impressive, huh?
yeah,
Kamil, how was the summit for you?
I haven't some.
Uh, Same.
Been
That's why I'm asking.
Oh, it was good. I
Yeah.
was on vacations for like 2 weeks. So
That's nice.
Um, just let me quickly pull up. So we don't have a fixed agenda. Let me see if somebody proposed anything.
I put some examples for the enum merging thing that I put a while back, but
That's
hopefully that clarifies a little bit. Uh,
awesome.
yeah, but it's mainly it.
Let's kick it off. 1 second. Okay, let's get started and then we can go through it. Okay. Hey everyone. Just as a reminder, by attending these meetings, we all agree to the GraphQL Spec membership agreements, the participation guidelines, the contribution guide, and the code of conduct. Also, these meetings are recorded and published on YouTube, and we may use AI tools for summaries. Let's start with a quick round of introduction. My name is Michael.
Hi, I'm Pascal.
It's Derek here.
Hey, it's Sachin.
Kamil from the guild.
Martin from Apollo.
Awesome. So as we have no fixed agenda, we can talk about the examples on the enum proposal from Sachin. Do you want to take over the screen and we go over?
Yeah, well, one sec. Let me make sure there's a go for this. Let me get the proposal.
Maybe you can quickly reintroduce it. I don't know if everyone was here.
Yeah, I
Coming?
can
Yeah.
reintroduce. Everyone see my screen? I think this is the right one. Okay.
Hmm.
Do I need to make it bigger? Is it too small?
No, it's good.
This works. Yeah.
Okay. But yeah, the gist is there was some in a proposal before that I think is specifically like there's I have to refresh myself on. It's been a minute since I last read this. Um, the gist was, I think, before the Apollo behavior basically for enum merging is a little confusing, to say the least, and it has a lot of cases where it can error out, which is not great for the user in terms of user experience. There was a proposal before, I think, around trying to simplify this a bit, but I think it had some shortcomings, so I tried to sort of list them here on what those were. Um, I think those are mainly around it was being intersect only, and so I tried to propose something new, um, where basically we could define for enum values whether they only appear in the output or only appear in the inputs whenever the enum is used. Um, and the idea was this can simplify how we do merge logic. Even if we only do it for just for the just for like the whatever is the executor, it can still simplify things there. So that sort of is the gist of it. Is that basically leads to a set of a set of rules which then make it so that you error out a lot less often in composition. It basically translates some of these things runtime error, so that it's easier to evolve the schema then, and also something that's hopefully easier to reason about as well. It's less you basically don't break as often, I think was the goal. I think these are the two main things it alleviates. So basically, there's no longer an exact match requirement whenever enums are used in both the input and output position, which I think is nice. So you no longer have composition errors there. And the other one is, yeah, I think that was the main one. And then similarly, when you try to suddenly shift to that one, you no longer see the error. Okay. And then I had some examples here to kind of show how that proposal worked in action. So I guess I can maybe walk through that if we good. Maybe I'll start with looking at the rules too, because really the only rules that kind of matter are these. There are some accessible stuff, but that's really just Apollo, specific and accessible stuff. We don't have to really talk about that much here. But the gist is when you see when you have enum in if you have enums marked with input only and output only at certain enum values, the gist is basically every time in a subgraph, if you see an enum used in the output position, at least, what you do is you'll compute some union U, where you take things that are non-input only from those subgraphs that used in the output position and put them together, unioning them into one set. We call that set U. And then there's a similar story for whenever a subgraph uses an enum in the input position, at least, where you intersect their non-output only enum values into one set, and call that set I. And then in U and I, you can then create an enum in the supergraph schema or the compose schema that then uses input output only and output only in a way that will enforce, I guess, things that you basically rules that you expect to make sense. Basically, you can't accidentally provide something that's output only to something that's so you won't see something that's output only in the input and vice versa. You'll see errors there. That's sort of the idea behind this. But that's sort of the gist of the proposal. But maybe the examples might make more sense, so we'll maybe run through those, right? So here there's, I think 4 subgraphs, just to show an example. Like in this case, you have a case where it's used in both the input and output position, some T, and you have A1, A2, and A3. And basically they just fan out over the possibilities of, nothing in case it's used in both positions. One is input only, one's output only. And then similarly here, it's just the input position, it's used in B. And similarly, there's a pattern there. There's one in T where it's used in the input position. Well, in this one was the output position. In this case, we have a little extra here so that our input set doesn't end up empty, just to make it actually look interesting in the intersection set I. And then another one here where it's used where it's nowhere, and that's just to show that if it's used nowhere, it basically just doesn't appear at all in any of the sets, or to illustrate that. And then this basically shows the set computation in a nutshell. So in the use case, what you do is you'll notice that the ones that use in the output position are this one and this one. And so you look at T here and T here, and you look at the ones where are non-input only. So it's basically A1 and A3, and then B1 and B3. Union those together. That gets you this set for A1, A3, B1, and B3. To find out you figure out where it's used in the input position, which is just here, and then here, and then here. So in this case, you look at the non-output only enums here. So A1 and A2 in this case, right? And here it's A1, A2, and then C1, C2. So you intersect those sets, and you get A1 and A2. And from there, if you see any things that are in common here, which is A1, that means in the output, A1 doesn't need anything. But other than that, if you see things that are only in U or only in I, then those things have input only and output only accordingly, right? So things that are only in the union are output only. So A3, B1, B3 have output only on them. Or A3, B1, yeah. And then this one is just only in I has input only on it. And so in this case, you can potentially compose schemas where you use the enums in both the input and output position in a way that works, and at runtime, it gives you the behavior you expect.
So basically, if it's not annotated with any of these directives, it's both sides. And also if it has conflicting annotations, it would be also both sides, right?
Yeah. So if there's in conflicting ones, there's a rule that we add here, either enforced by composition or enforced if this is a GraphQL spec thing, then enforced by the spec. That says you can't put both of these on the same enum, right?
Yeah, but different subgraphs could have conflicting ones, right?
No, but that's okay. That's okay.
Because it could be on subgraph B, it could be input only, whereas it's on subgraph A, output only.
Right, but this is relative to its own subgraph, right? Like
Yeah.
these annotations are not relative to the whole, they're relative to just the subgraph that it's on, is the idea, right? So it
Yeah.
could be output only here, and it could be input only somewhere else. That's perfectly fine because the annotations are more limited, describing constraints that only apply to the individual subgraphs. So that's okay if
Mhm.
they're different. It's just in the same subgraph, it doesn't make sense to really do it in that case. So.
Yeah, that
And
makes sense.
they would, if one subgraph defines it as input only and the other subgraph defines it as output only, it essentially cancels out the annotations, right? It's in just
Yeah.
an even value without annotation. Okay.
Yeah, that's right. That's right. Assuming that it's actually used in those ways, but yeah.
Yeah, so that's also metadata that some implementations which use supergraph schema probably will have to store there as well, right? Did you know which, because it's subgraph local configuration, right? You have does the gateway have to know?
So this algorithm guarantees that this complies with the constraints implied here, right? That's
Yeah,
the idea.
true. But when you have something like when you provide a value to, let's say one subgraph defines a value as input only, other subgraph defines it as output only. Yeah, it's easy. Then you can just pass it through.
Well, so the question would be, it's defined as a schema, right? And implies that the clients are aware of those, because like if they pass in A3 in this example as an input, that would be a runtime error unless the gateway or router is aware of those and actually performs this validation.
Yeah, like in a world where we don't have this.
I'm looking at the API schema at the end, right? So that's
Oh, this one, yeah.
yeah.
So
that's this one says A3 is output only, but if I pass it as an input to BAS, that would result in runtime error, right? Saying
right. So the executor here would essentially run the validations that were sort of implied here, right? Around the coercion rules, right? So like that just is if it did get A3, it would see that A3 is output only and then error out accordingly during coercion.
What about the case where two subgraphs define A1? Let's say one subgraph defines A1 input only, the other subgraph defines A2 input only, and there's two root fields, subgraph A, subgraph B. You're still able to pass something to a subgraph that it doesn't understand, right?
Well, if they don't, either of them have no intersection, the intersection becomes 0, in which case none of them get propagated to them, to clarify.
Right, true.
Yeah. And in that case, basically can just pass null. So there's some precedence for this in the GraphQL spec where you can actually have interfaces that are implemented by nothing and they can only return null in the spec. So I mentioned that's actually one of the examples I have below here, where yeah, in this case I think it returns T and then there's an A1 that's input only, and so basically this thing is just forced to always return null. And there's an analogous case above where you can have an output only A1 potentially being where this T is as input somewhere. In that case, you can only give it null without it erroring in that case. But the spec does sort of allow this kind of thing to begin with, so the intention is that we could do something similar there. But
Yeah, I mean, there's
what is with
right? It cannot be non-nullable because otherwise you run into issues.
what is
yeah,
with shareable fields that have different input definitions? Like where on one subgraph you have other enums, and on the other, do we use it as planning thing that we say, okay, if this is going in and it's shareable, we have to actually go to this subgraph because only there it's valid.
if it's shareable, then well, basically it's guaranteed to be valid. Like the merge definition is guaranteed to be valid regardless of which subgraph you use, right? Because that's why the exception is there, right? Or
yeah, what I mean more is like let's look at bar, right? Bar has an input T.
yeah.
And if bar is shareable, then we have it on two subgraphs. And it technically could have different definitions of what can be inputted in each subgraph, right?
True, yeah. But in this case, or in this proposal at least, like it would be guaranteed that regardless of whether it could accept A1 or not, it would still end up erroring out due to output only semantics, I guess. So it wouldn't be the case that you could accept A1 in one subgraph and then the other one it doesn't accept it. This is also in line with how shareable works with, or at least in Apollo Federation, when you mark a field as shareable, it is assumed that it doesn't matter which one you choose, just they have similar behaviors. So in that case, it shouldn't matter whether you provide A1 to one or the other, it should have the same behavior. So differing behavior there is also kind of a smell. So that's also why we sort of do that. But yeah. At least that was the intention behind shareable, at least, is it shouldn't like matter which one you pick, so the behavior should effectively be the same. And so,
Yeah, I was more like if it's an input, if you have let's say we have on subgraph 1, A1 as an input only, and on subgraph B, we have A2 as an input only, and a bar is shareable, but it has like now different enum values that you can input on each subgraph.
right. So in that case, the output, the enum that you would see in the merge schema would have no input. It has nothing that could be inputted to the thing, right? It's basically similar to this case here, because in this case here, I think we have A1 and B1, or in this case, it's a little different, sorry, but like you end up potentially having nothing that you can pass to input here, and it would always error regardless. Even though one subgraph accepts A1, the other accepts B1, we essentially say that both of them
It
can
actually
accept.
should already be a composition error in that case.
Yeah, it sounds like it should be a composition error because I know in some cases in Apollo Federation we do have cases where we notice if shareable fields differ in that way, we will error out saying that you've basically you're not adhering to the shareable contract in some sense. But or at least what you could assume there is that it could be a temporary state, so we might not actually error out. We just assume that what you really meant to say was that nothing can be fed in except other than null. Might be the other thing. Because there are temporary states where if you're migrating, it might differ by a little bit, and we don't want to error out composition when you're migrating or like when you're updating each subgraph individually. So it might not be the case that we'd require exact match there. I
Well,
don't actually know
so
the exact numbers,
my
but-
question is, should that be actually just filtered out? So if the argument T is never satisfiable based on the rules, so there's no value of T that you can pass there that would pass, should just the argument T be dropped? Same thing for the input only if they're, if the query returns something that it cannot, should that be filtered out and not be present in the API schema altogether?
it could be an
Otherwise,
option.
you're saying like, yeah, I have this, but it's always going to error out, which seems kind of odd.
Well, it could also just return null without error, right? And it could also accept null without error. So it's possible to do these things. In terms of whether there's actual use cases in the wild, I'm not so sure. I just know the GraphQL spec does allow this for the case of interfaces, but I don't know if anyone uses this as a temporary like intermediate point. Like if you're just starting out and you're trying to return interface, but you haven't defined the implementation types yet, you might put out the field, but you don't have it returning anything yet. I don't actually know how common this is though in reality. I just know the spec has an allowance for this where it does allow you to return an interface with no implementers, and that's technically valid. And the only thing that happens at runtime then is it always has to be null because there are no implementers for the interface.
So what I think we have to come up with a couple of composition rules for this, like where
Yeah.
we want to. It could also be like in the case where no input is possible. It could also be that we want to have a warning there in the composition case, because it could also be an error, right? That you
Yeah.
have this mismatch. It could be a transitional state, but it could also be an error. So having a warning at least there.
That's
Yeah.
right. Yeah, a warning sounds right. Or like that's what generally a federation, I think, or composition will do. If all its composition is, it'll put out a warning at the very least, but it won't elevate it to an error in case of a transitional state. So that's
Yeah. Yeah. Also for the output state, we have the same case, right? Where there is no valid output.
Yeah.
In this case, we should also have a warning. I think we should go through that and see what composition rules should be in place here.
Well,
Yeah.
there are the merging rules already that are up in this issue, which are already pretty spec language like. So they are very accurate. I think what we have to make sure is that everyone plays around with this and understands the behavior, and then we somehow have to find a way how we teach this to people. Like the idea is to make it simpler for everyone, right? And what we avoid with this is that there's less potential for a runtime issue. And at the same time, we have to figure out how do we teach to people how they get their enum values there, right? Like if we just talk about enum merging, they might expect that when you have an input field, an enum for an input field into graphs, and one defines A and the other one defines B, then you have an empty enum, you know. But they have to.
But I think this is less now, Pascal. I would actually say you have now more runtime errors, but less of these surprise cutoffs, where suddenly you have two enums that have these values in there, and suddenly they're reduced to nothing.
But
Yeah,
where's
it's
the
mainly around. I'll let you talk. Sorry.
yeah, go ahead.
But yeah, the main idea here was just to reduce composition errors around like the exact match requirements. Because that was definitely a point of sticking is like, when you suddenly have to like, if you suddenly start using an enum in a position that previously wasn't used in and it was already used in the other position, then suddenly you have to like basically make all the enums across all the subgraphs match. And it's a very painful experience for the user then in that case. And so this basically avoids that by making it a lot more graceful. It does mean more runtime errors, but arguably users are fine with this compared to as long as they understand the semantics of it, right? That's the idea.
And I think
presumably-
we can fill that in with warnings, composition warnings, and users can choose to upgrade them to error if they want it more strict.
Yeah. And presumably if like eventually these find a way to make them into client code or client generated code, then then it actually doesn't necessarily issue runtime error because then their client code can guarantee they don't get the runtime error, right? That's the other side of this, right? So the runtime errors technically are more of an issue that are generated in this case, or more around people not knowing something is input only and accidentally specifying it as input, and vice versa for output, right? But if you have a world where code gen and client side knows about this, then you also don't really encounter it there.
Yeah, so
But
the problem is only present when you put in an output only value into an input position, right? That's the only place where runtime error can occur.
well, the runtime error
That-
can occur if someone puts something that is output only into an input position, then it can cause an error. And similarly, if a subgraph happens to return something invalid, that will also do it, right? The subgraph
Sure,
shouldn't.
yeah, but that's something that always will that
Yeah,
will
yeah.
always happen unless we say we don't care.
Yeah, that's right. That's right. In terms of the client we're concerned, it's mainly around that. But yeah.
Yeah. I also think that the spec should be we can write a note that you can or you cannot validate enum value return values. Like you can explode and you can say like you return something which is invalid because the subgraph returned a new value which is not in the enum. For example, an input only or an invalid one, D1, D2, D3, something like this. If this is returned, then there can be an error, but I think the spec should also say that we do not necessarily enforce it because that leaves it open. If you don't care about this runtime error, then it could just be a gateway flag, right? You could say, I care, I do not care.
Yeah. I mean, yeah.
It doesn't hurt. Like if, let's say, the Apollo gateway and the Hive gateway strictly do this validation. Like it's still spec compliant. Like it's not a problem. And then there would be another implementation which says, fair enough, we have a customer which really needs this, and then they just let it through, and it's still spec compliant.
I mean, that's what Netflix does. And from Lee's point of view, it's this spec compliant if it's transitional state. Awesome.
Yeah, the only thing that I have at the moment as an issue. I mean, I have to understand it first completely. It's just how we are going to explain this in simpler terms. Like this is very good for specification because it's very accurate, you know. But how do we put it into docs for people to understand, right?
Yeah.
But the good thing here is actually how I understood it is that it's actually a GraphQL schema concept. I mean, it influences how we do composition, but it's first off an isolated concept for schemas. So the local GraphQL service actually that describes that and describes that for itself, like an isolated thing. It can influence composition, but like first and foremost, it's and I think that's the way also you framed it. It would be kind of an extension of the GraphQL core spec.
Yeah, this could be a GraphQL. It could be an extension of core spec. It'd be nice if it were, because then it could be more easily visible to users and introspection and the like. But it could be composition only, where people annotate it and it goes up and the executor enforces these requirements. But yeah, it'd be nice if it were a spec too, a spec addition. But sorry, there was one other thing I wanted to mention, but now I lost it. Sorry. But what was it?
Kamil, do you have any thoughts?
Oh, sorry. It was around the how to intuitively explain this, but I'll let Camille say his thoughts there. Sorry.
No fuss really. I mean, I like this approach.
Oh. So one way you could potentially intuitively explain this is that GraphQL spec is currently sort of, in this weird place about enums where they can be used in two positions, and when they're two positions, they have very different semantics. And so what we're really doing is encoding two separate enums here, one that's input and one that's output. And what's happening then is for each of these encodings, we're intersecting the ones where it's inputted and unioning the one where it's outputted, and then merging them back together, basically. And that's kind of mentally the model that I've had with this a little bit. So
I wonder what this means for code gen, for example.
yeah.
Like for like let's think about native clients, because that's where code gen is most strict. So you probably do want a separate generated like Swift struct for your input and your output enum in that case.
Most languages will want that, yeah. Because I don't think most languages can represent this kind of thing in their enum, existing enum.
No. I mean, maybe TypeScript can. I mean,
Yeah,
it can basically represent basically everything. There's a full language in the like type specification.
Well, not surprising TypeScript could do this, but
Yeah. But for Swift, I mean, and I think that might actually be a good way to look at this, to look at how to explain it. Like, I like the conciseness of this model. Like like you don't have to duplicate the enum, but maybe duplicating the enum is actually the more straightforward way of specifying this.
the upshot and downshot essentially is that sometimes you'll have common values and you don't want to duplicate them or manually copy paste them between the enums is the thing. Or sometimes you want to
Yeah.
represent that actually are the same enum, but in some cases you actually do have inputs like things that were deprecated in the past and you don't want to like break people that are input only in that case. Or some things that are output only because of a similar sort of thing. But
Also,
Derek.
oh yeah, sorry, Derek, go ahead.
Yeah, I was gonna say, like, if we're looking at from the cogent perspective, yeah, they would probably generate two separate things, which warrants the question: should the API schema generate two different things out of it? It's, I guess, the argument against it is that you want to do the conversion from one to another, right? You would need that instead of using it the same thing in two places. But mentally, that would actually be probably simpler, having like this is the input, this is the output. But I don't know.
Yeah.
Yeah,
It would
I
also
mean,
be
you can do that, right? You could do that in the past, and you could do that in the future. You could just have two, and nobody would hinder you.
It could even be a preprocessor that you optionally allow in composite schema. Like it's completely valid to do this, right? You can completely it could be a gateway feature. Like you don't necessarily that doesn't necessarily need to go into the core specification. But this what we try to solve here is a core problem that we have, right? We're just trying to solve we try to somehow solve it in an elegant way.
Yeah,
Splitting
because the key one thing, the key issue is that people do this. They have these combined enums, and what we are solving is basically if you have these combined enums, then this is your solution, or this is one solution that we have.
I personally believe output only and input only enums are great for various reasons. But I think it's probably something that you have to build into your API design. Like we would have to define rules how we want to name these two now. Like this now is called the T input, and then we have the T, which is only the output, or do we call it the T output or whatever? You see the problems that arise from this. And I think generally having input only and output only enums are great. And with this approach, you can even share them across different services. Like if we follow this approach, it will just work.
Yeah. Like it's nice when people can do that sort of input output thing, but it means basically people have to change their APIs manually to do it, and it's a breaking change for everyone. That's sort of the other thing, and yeah, this sort of like it lets you sort of do both. Like you could actually split your enums now, and it would if you use these composition rules, it still just works basically as you'd expect it to. So even for people who are already doing splitting and people who aren't wanting to do splitting and use this instead, it works in either scenario. So that's the upshot, but yeah. The main thing is just backwards compatibility. Or like, we have an ecosystem we can't break everybody. So that's the benefit here, but to some extent, but
Awesome. Anything else on this topic?
no, I mean, if anyone else has any other things they want to, put down or any questions, you can put them in I suppose the spec thread, or I'm sure folks will have to like read this more carefully to get a sense of like weird edge cases and like I tried to put some of the weird edge cases with examples 2 and 3. So that's why like I made those particularly obtuse in terms of definitions, but yeah, if there's any other cases people want to discuss, we can go more in detail in the thread. But yeah, I don't have anything else for this. So
Awesome. Does anybody want to discuss anything else? It's still 20 minutes or so.
One thing I wanted to point out is that like with this enums being input and output, it will kind of change a bit the way people use cogents now. So the source of like it cannot be really like GraphQL schema or like SDL or whatever. It cannot be really also introspected. So then like it eliminates a bunch of tooling that, like for example, the GraphQL cogent will have to get I don't know, whatever format we will, have or different vendors will have to introspect it. So it might be a bit challenging to generate those like input and output enums in code.
It's a good
Yeah.
call out.
If it's not on the spec, it's a problem.
API schema is generated, right? It's kind of like, and you cannot, introspection doesn't have directives in it, so you would have to generate API schema in some SDL format somehow. But
Yeah,
Depends.
Yeah.
If we get it into the core spec, this problem wouldn't exist because it would be a property of enum value, like we did with deprecated, which is also not really a directive, but more a property of this thing.
And I think we're doing the same thing with one-off, right?
Yeah, the one-off is also the same thing.
Yeah.
Basically, on input you have is one-off as a thing.
Yeah, and I think it's somewhat similar to the one-off case. Like it's adding an additional semantic restrictions on top of the existing type system.
Yeah, like the changes to introspection are pretty straightforward, but I don't know if we can really edit the introspection types without the go ahead of the it being in the spec, I guess.
No, yeah, I can find out the appetite that exists within the TST for this, and also talk to Lee. and then we can try to get it into the core specification, which takes long, right? So at least a year, I would say. would say from past experiences. But it doesn't matter, even if it's like in our opinion, we anyway implement things that are in draft state, and that can be faster than being merged, right?
That's true.
So,
yeah. Okay.
So let's see how people feel about that in a greater group for the core spec. I think for the composite schema spec, it makes sense. But like if we want to give clients also the opportunity to inspect this kind of thing, then it must be in the core spec.
Yeah. Yeah. You need some out of bandwidth. Giving the
Or
schema
we
otherwise.
solve issue 300.
Yeah.
Just
That's the
300.
Or, there's also, like saying that composite schemas, compatible router now exposes underscore service SDL that returns your API schema with all this stuff.
Yeah. We make our
And-
own version of introspection, basically. Just for executors.
So regarding this, Derek, what we made the experience with is actually it's much better to
Yeah.
use in a different transport than in GraphQL. So just put an endpoint there and return it is much, much better than having it go through the GraphQL engine for no reason.
Yeah, what we do is basically we have a slash GraphQL slash schema.graphql, and that's always mounted, has no compute, and basically it's totally cheap. And people tend to switch off the introspection and just have the file mounted there for code gen and stuff like that.
Yeah, we did that, something similar like that in my previous life.
Yeah, it's actually, we should standardize that. I think if we agree to a route, this would be very good to have the schema just there.
What's the work group? Is it the HTTP work group?
HTTP working group. We have to go to Benji.
We have.
I will talk to him.
No, that would actually be good because that would be much better than, I mean, the introspection is powerful, but in 99% of the introspection, you just need the schema file. So
you run introspection to convert it back to SDL, right?
It's
Well,
often done like this, right?
well, it's the main, I would say it's the main use case.
Yeah. Theoretically, there's a backwards compatibility thing where if you add a new directive
exactly.
to the vector spec, where you don't want people to like suddenly error out on an unknown directive, then you don't want it in this game.
Yeah, or keywords. It's actually around keywords. If, for instance, we introduced a repeatable keyword in the directives, and that would have basically crashed any tooling that didn't understand this keyword yet. But it's like it could be if it's
it breaks the ecosystem anyway.
Yeah, no. You can still introspect, and you wouldn't just see these things.
Yeah, I know, but
we can. Yeah, as a convention, it would be good. Like here, you can probe for the schema GraphQL file there, even if introspection is switched off for security reasons. You could have the file there. Anyway, if there's nothing else, we can close off 20 minutes early, and then reconvene next week.
Sounds good.
Awesome.
See
See you guys.
you next week.
Yeah.